Hello, my name is Rosalie Gagnon. I am an undergraduate student at Grand Valley State University studying pre-speech language pathology, and I'm going to present to you today a pilot study on the effects of emotional singing on the production of airflow vibrato. And it is co-authored by Dr. Nandamudi, an assistant professor at Grand Valley State University, and Dr. Ronald Scherer, a research professor at Bowling Green State University. So going into some background terminology, airflow vibrato isn't as commonly known. So it is the airflow variation during singing that will accompany the more commonly known vocal vibrato. And common measures of vibrato as a sine wave that will be seen throughout this presentation are rate, which is the number of cycles produced in a second, extent, which is the difference between a peak and a valley in one cycle, regularity, which is a cycle-to-cycle variation, also known as jitter, and waveform shape, which sees how close the sine wave is to approaching sinusoidal or quasi-sinusoidal qualities. So the vocal expression of emotion in general has been studied for a long time. Different parameters for emotions have been noted. And specifically for vibrato, it's kind of up in the air right now. It's not determined whether emotion does affect vibrato production or not. There are some studies that say that it does, and other studies that say that it does not. However, overall, there were no previous studies on airflow and frequency vibrato changes secondary to emotional singing. Therefore, the purpose of this study is to study the frequency and airflow vibrato measures between 5 different emotions. These are happiness, sadness, tenderness, anger, and a neutral emotion. So there are 4 research questions here. And we're going to be looking at if there's a difference in frequency and airflow vibrato, rate, extent, and regularity between the emotions, if there's a difference in vocal intensity, and in mean airflow and mean fundamental frequency values between the 5 emotions. So for methods, this is a single subject study, a part of Dr. Nandamudi's dissertation project data at BGSU. Studied a voice faculty member at BGSU who was currently an active Western classical soprano singer with over 15 years of experience. She volunteered and signed a consent form before proceeding with this project, and she was asked to sing the Star-Spangled Banner with the 5 emotions I mentioned earlier. And she sang from the beginning of the song at O until the word gleaming. So this is a schematic of what apparatus was put on the subject. This is a circumferentially vented mask that the subject was wearing, and there's a tube in the subject's mouth that leads to these 2 transducers, which measure the airflow and oral pressure during the production. Furthermore, the subject wore a headband that had a microphone attached to pick up any acoustic data. And finally, they also wore an EGG, although the EGG data was not used for this study. So all 4 of these signals were sent to an analog to digital converter and analyzed on a computer using Windac software. So again, here is a list of all the equipment used in the study. And for the actual data analysis, 8 words were selected from the song based on perceptually strong expressions of emotions. And these are the 8 words right here. And around 4 to 5 vibrato cycles for each word were measured, and they were averaged to obtain the rates, extents, and variabilities shown later on in the results. And the descriptive statistics would be the means and standard deviations of all of the frequency and airflow vibrato measures. So to analyze the frequency vibrato, it was analyzed using Praat software at 10 millisecond intervals, while the airflow vibrato was a wideband signal, and it was smooth using the MATLAB custom software. Smooth just to get rid of any background noise and to eliminate that, and also to downsample it to intersample intervals of 10 milliseconds in order to match the fundamental frequency samples. So here's some results that we have here for the raw data for the word proud, and this is between the emotions angry and tender. So while both have similar frequency and airflow vibrato rates between the emotion, the duration of the vibrato with the emotion angry is actually shorter than that of tender. Furthermore, we see here the black line represents the frequency vibrato cycles, and the red lines represent the airflow vibrato cycles. So for tender, the frequency and airflow vibrato cycles are very smooth and consistent between all of the cycles. For angry, while the frequency vibrato is fairly smooth and consistent, The airflow vibrato shows more complexities, such as here, the 2 peaks at the top instead of just 1. And that shows, it indicates that there are more complexity in the production of airflow vibrato, leading to these incongruences. Again, we see here, this is the word see, and between the emotions happy and sad. So happy had a slightly faster frequency vibrato rate compared to sad, but they had similar airflow vibrato rates. So, and again, similar to the last slide, happy had a shorter duration than the vibratos for sad. Sad is closer to tender that we saw in the last slide. Okay, and here we have, at the bottom here, this is the chart showing the relative measures of all 11 variables for the word oh. This is a word at the beginning of the song, so it was thought that this word would have strong emotion attached to it from the singer. And these different colors represent the different emotions. And right now I'm going to focus on the light blue, which is happy, and the yellow, which is angry. So starting with the mean rates, the mean frequency vibrato rate is very similar between all 5 emotions. The mean frequency extent, however, frequency vibrato extent, had happiness higher than the other emotions. And then the mean airflow rate and mean airflow vibrato extent had anger as the highest emotion. For the variabilities or the standard deviation, we have the frequency vibrato rate and extent and the airflow vibrato rate and extent. The variabilities were all highest for angry, indicating that the vibrato the singer used for the angry emotion was more variable and inconsistent compared to the other emotions. And then for the average fundamental frequency here, it was fairly similar between all of the emotions, with the exception that anger had a slightly lower frequency, indicating that the singer used a lower tone, perceptually lower pitch. And then for the average airflow, happiness was much higher than the other emotions. And intensity, all of the emotions were fairly similar to each other, with the exception of sadness, which was slightly lower than the other emotions, which shows that the singer chose to use a quieter tone in general when she sang sadness. And again, similarly here we have the word light. So this is a word more in the middle of the production of the song. And here again, we see similar patterns for happy and angry being higher than the other emotions. Especially here we see for the mean and variation for the frequency vibrato extent. Happiness and anger are the highest, and again over here. What was surprising for this word is that the variability for the frequency rate, frequency vibrato rate, is highest for neutral, and this was surprising and different than the previous word. So other interesting observations seen, the duration of the song for the emotions sadness and tenderness overall was longer compared to the other 3 emotions. Anger was seen to have the higher average airflow, frequency and airflow vibrato extents, faster frequency and airflow vibrato rates, and more variability, followed by happiness and neutral emotions. Tenderness and sadness furthermore displayed lower average airflow and less variability in airflow and frequency rates and extents, so they had a more consistent production of vibrato cycles. No significant differences overall were noticed in vibrato rates. It was around 5 to 7 hertz, which is consistent with previous literature, and the average fundamental frequency and vocal intensities didn't really change with changes in emotion. Future directions to take the study are to have a larger number of subjects to determine whether this is significant between singers, and a few variables related to airflow would like to be fixed with airflow. Furthermore, EGG values, along with laryngeal imaging, could add more value to this study, and a perceptual study to correlate the listener's perception to the subject's intended emotion should be done in conjunction with this future directions. Thank you very much for listening. I know none of this is like any of us are thinking it's going to be. Thank you especially to the Voice Foundation for still giving us this opportunity to present the research. Thank you and have a wonderful day.